Welcome to this presentation on output equation. We will explain the need for an output equation. We will illustrate it with an example and then we will present the state and output equations together. We have already informally introduced the state equation, which is x dot equals ax plus bu. State has all information about the system. Knowing the state at one time, we can compute all future values. For instance, the input variable is denoted by u of t. Input could be either a disturbance variable or a manipulated variable. And we also obtained the discrete time equivalent as follows. We also need the output equation. Why is it? It may not be possible to measure all the components of the state. For example, it could be expensive. Measuring the temperature in all trays of a tall distillation column could be impossible. There may also not be sensors, for example, rate of change of viscosity. We often measure only a subset or a function of the state vector. We write down the equation of the output as follows. Y of t is cxt plus dut. We will see an example of this. Suppose we have two components in this state, x1 and x2. Let us say x1 is the height of liquid 1, x2 is the height of liquid 2. Both are present in the same tank, one above the other. Suppose we measure only level 2, then we will write y as 0 1 times x1 x2, that is y is equal to x2. If you multiply this, you get x2, and you measure only the height of liquid 2. Suppose we measure the total level, then what do we have here? Basically we have to add x1 plus x2. Here I am interchangeably using level and height. Here I am measuring only height 2. Here we are measuring only the height of liquid 2. Here we are measuring the height of the total liquid. So you get 1 1 times x1 x2. If you multiply this, you get x1 plus x2. We model this as cx plus du, where the value of c is different depending on the situation. If you measure only level 2, c is 0 1. In this case, c is 1 1. In both cases, d is 0. In this slide, we will present the state and output equations. Here is the continuous time output equation that we used in the previous slide. We convert this into discrete time equation by synchronizing the sampling of input and output, so that at the same time instant n, we would sample u and also sample y and sample the state x. So here is the complete discrete time model. X of n plus 1 equals axn plus bun, yn equals cxn plus dun. We will use this model in the rest of this course. That brings us to the end of this presentation. Thanks for joining.